right, well guys, welcome to the applications presentation. I'm just going to be talking about how you apply the Q-PAC fan and fan replacement situations. And we're going to go through a couple different things here. So basically how you're going to size it, things you're going to look out for in the air handler, backdraft dampers, why we don't like them, some clearances with where to actually mount the fan inside the air handler. We're going to go over structural supports a little bit. Sometimes you do need field supports to make a project work, depending on the project. And then just a couple of specific applications for you to look at to see kind of the breadth of things you can do with the fan. So, all right. So the first thing is typically you want to just make sure you have all these things when you're going into the field. Pretty self-explanatory. You want to measure, I think most of you guys already know this, but you want to get CFM, total static pressure, the interior width and height of the unit, and the supply voltage. Typically, as far as like sizing the system goes, you're going to have maybe a schedule available from the existing unit, maybe some old plans or something. You can use the design CFM and total static pressure to just get a budget going. Before we actually build the product, you typically want to get it more refined than that. So you're going to want to maybe do a test and balance, or if they already have one, you'd want to do that. But the internal height and width of the system is kind of like really what you want to start paying attention to, because if it's just a regular air handling unit, it's a solid metal enclosure. You just want to give us those internal dimensions, and we're going to mount the perimeter angle around the perimeter of the inside the unit, and then we're just going to put each panel on it as it goes through. So getting those dimensions correct is really important to the actual product fitting in without any additional sheet metal or anything. Sometimes I think it's usually better to oversize the width and the height than it is to undersize it. If you oversize it, you're going to have a reduction in your cost. So when we determine, okay, it's not 120 by 120, it's more of 100 by 100, you're going to have a lower cost there as well. So that can kind of help buffer some things. But yeah, make sure you bring all these things. You want to measure the internal height and width. You want to get the access door as well. So how is the product going to get into the unit? I think you all know that we ship the product for retrofits as a palletized solution. So it's going to come in on pallets. You're going to have your bulkhead wall panels, your fans, and your control panel, and quick connect box all on separate pallets. So it's easy to get it in there, but you want to make sure you've got enough room. Typically, you want your access door to be a couple inches larger than the fan depth, so you can slide it through and out. Like for example, if you're going to have to swap out a fan if one fails, you want to make sure your access is large enough to get it through. So it's a big consideration. Just bring a tape measure and just check that access door. Also, you could bring a manometer too if you want to actually measure the static pressure inside the unit beforehand. So that's another just consideration. Okay, I kind of went over that. Another thing that's important to know is the existing electrical information. Does the customer have a existing breaker or existing disconnect? Do you want to match the MOCP on that? Is that important? If you select a system, either if you have QUIPS access and you're running all that on your own, if you pick a system where the MOCP is larger than what's existing, you're going to need to change out the infrastructure. So you might have to get another breaker, you might have to run different size conductor, and that can add cost to a project and get you in a little bit of trouble. So if that's a concern, just make sure you're matching the MOCP. Make sure you pick the selection that has the lowest power consumption. That's one of the things you really want to check on a job. And sometimes that information will be on the schedule, but other times it won't. So if you're working directly with the contractor or if you're working with the end user, you definitely want to get that information. So, in situations where you don't have the static pressure or the airflow, there's some methods that we have to calculate them. So if you don't have the airflow, you can typically measure the coil face, and then you can say, all right, that coil face divided by 500 feet per minute is a good approximation of the CFM. So typically when a project is just getting going, you're going to look at it and say, all right, well, what's my budget going to look like? And before you actually dial in all the other information. So only problem with the test and balance is that if the fan is in really bad shape, then you might not have an accurate, it might not be meeting the performance requirement. So in those cases, you're going to need to look more at the HVAC design of the building. You might need to look at that schedule again and the plans to get more information to understand, okay, well, what do they want to be at, and where are we now? So that's something you want to be aware of. Let's see what else we got. That's a way to approximate the CFM. You can also, as far as the static pressure, sometimes if you give us just the horsepower of the existing motor, we can do some approximations in QUIPS. There's a quiz presentation in that room. They might go over some of that stuff, but basically there's a general relationship between the size of the system and as far as performance, airflow and static pressure, and the actual horsepower of our system. So our submittals are going to report total horsepower and individual horsepower for the ECM assemblies. So you can just look at that total horsepower. You can, let's say you start at 2 inches of static and 35,000 CFM, and it's and the total horsepower of the system is horsepower or something. If you just increase the static pressure, you'll see that horsepower increase as well. And then if you get to a point where it matches what's existing, that's usually a pretty safe bet for a budget. But the main thing is, budgets are one thing, but when you really do want to go to order the system, you do need to do some more digging and research into what's existing. So the scope, as far as the scope does really fall, the engineering of the project does fall on the rep or on the person purchasing the product. So there's something to be aware of. Some sizing limits. In general, I think Q-PAC is a great product for supply fans, for chilled water air handlers. If you're between 2 and 8 inches of static pressure and I said 8,000 here. Really, you can go as low as 5,000. But when you get under 10,000 CFM, you usually only need one Q-PAC or one ECM plug fan to do the work of that fan. So it kind of like away from the inherent redundancy of the system. So I tend to say if you can go up closer to 10, 15, 20,000 CFM at your entry point, that's where you're going to get a 3 or 4 fan system, and the redundancy really does help out more. But in general, the efficiency is there when you're between 2 and 8 inches of static pressure and 8,000 CFM, 5,000 CFM and up. I mean, we have some massive systems out there, like 250,000 CFM. You'll have maybe like 60 ECMs on a plenum wall inside of a mechanical room. Some of the projects that the Weikerts were talking about out there, they're massive. So there's the sky's the limit. If you can fit the fans in there and it fits the performance requirements, then you're good to go. So there's minimum dimensions here as well. That's more just for quips. The quip selection tool is the configuration tool we use to do probably 90% of our projects. There are some situations where the project scope is a little outside of that, and there's a feature called a special request. We're kind of changing the languaging, but it basically just allows you to do something custom. So if you're using quips and you can't get a selection, you'll submit a special request, and our product engineering team will see if they can make it work. Sometimes you'll have systems that are below 1 inch of static pressure. That's a case where that comes up. If you have more than 18 fans, that's another one. And if you need to exceed these dimensions, if you need to go larger than 280 wide by 140 high, you also need to do a special request. So that's just something to kind of keep in mind if you're just running through quips and doing selections.
How come it's 18 fans?
Because that's actually what that is the 280 wide by 140 high limitation. So you can really only get up 18 on. And that's going to be a larger control panel as well. It's going to have 2 quick connect boxes, so it'll really be up to 2 Q-PAC fans per system. So if you need to go larger than that, let's say you have a larger system, you'll need to also go through that special request system. So, all right, dampers. You'll probably know, but let's see, if you lose it, typically with fan arrays, if they're independently controlled and you lose one, you're going to want to have a backdraft damper on the back to stop recirculation of the air. In our case, we really don't like backdraft dampers because we think they're kind of an energy leech. They're going to add static pressure to the airstream. If you're putting something else in the airstream, it's going to increase your static pressure. So we really discourage the use of backdraft dampers. They are available, but we like to kind of say that if it's not a critical application, if you're an office building or a school or something like that, and you have a fan go down, and if you've selected for 100% or higher redundancy, then you can just turn the unit off for a few minutes, go in, take the fan off the wall. They're designed to be easy to install. You can just unplug the plugs from the ledge, undo the bolts, and you'll have a blank off plate you'll be able to put in its place. So that'll prevent the recirculation. Then you just get out of the unit, turn it back on, and it's going back to normal. So it's all our alternative to that. And also dampers are another thing to actually have to install. There's a damper channel that's going to be on there as well you have to put on. So it just increases the installation time as well. So we just try to avoid those. There are certain situations though where, again, if you have multiple control panels in an airstream, let's say you have one of those massive systems that we couldn't fit all the quick connect boxes, all the electrical on one control panel, and you have 2 control panels, you probably would want to use dampers in that situation, just in case there's a difference in the ramping up of the 2 units. But 99% of the time, you're going to have 1 control panel. You're not going to want to use dampers. Okay, for clearances, the rule of thumb here is that 45-degree transition. So if you take your fan inlet and you kind of like drew a box around it, right, a rectangle around the edges of the inlet cones and to where they're tangent to that line, if you have a 45-degree angle from that to the edge of the coil, you're good. And you really want to maintain either that 45 or a larger angle than that. Once you get lower than that, you can have issues with, I think, some stratification issues with the airflow through the coil. But in general, it's not a huge deal, but it can be an issue if you have a large enough system or if you have a smaller coil phase or something. So that's kind of just a rule of thumb, is that 45-degree angle. In general, when you're pressurizing a plenum, though, as far as the discharge side, this is the inlet side, but when you're pressurizing a plenum, typically you don't have to worry too much about uniformity of the airflow through the outlet. So, and I'll kind of be on the next slide, but here's just another example of you're able to save a lot on space. So using the Q-PAC option here versus using the AC plenum fan, you actually have a lot less space for the air handler on the Q-PAC side. So you can design a smaller air handler. Little background there. I don't know how many of you guys know this, but we started out building custom air handling units. We were a company called Mass HVAC. So the ECM fan arrays became really popular because you could reduce the footprint of your air handler significantly and way decrease the cost. And it was really popular for that reason. So this is kind of reminiscent of those times when we were doing a lot of new Daikin units. But it's great for retrofit too. I mean, if you have less space that you need to install the wall and you can move it around more, it's more wiggle room. So just another example there. And then for downstream, I think, let's see, what's it say? It says it requires more distance to develop on the discharge side for the AC plenum fan. Again, I don't think that it's that big of a deal, but but the rule of thumb is at least go 1 fan diameter away from the coil. So I would stick to that. If you're worried about it, you're sizing a unit, and you're like, hey, give me a call or give your account manager a call, and we can go over that with you and see if it's appropriate. But in general, you want to do 1 fan diameter away for your coils and your outlet are going to be. Okay, then for situations where you have a top discharge, typically just make sure that the fans are, there's this rule of thumb about the hypotenuse and the directing surface, but mostly just try to keep the fans away from the actual discharge. Like the end of the fan here should be behind the opening where the discharge is. So just avoid that. If you could also, alternatively, you could also add a sheet metal piece here to direct the airflow better, but I don't really think it's as much of an issue. I think it's about to come up here, but there are situations where if you have, depending on the type of discharge, if it's a top discharge and you can just get away with a single row, you can actually put those you can put those underneath that outlet. And then if you have a situation where the discharge is to the side, you can do a single column. So it's another way to get away with that. All right, structural supports. I mentioned the perimeter angle earlier. That's the L bracket that we ship with all of our retrofit products. It's going to mount on the inside the actual air handler and the air handlers. But if you have a situation where it's a built-up unit, you might need to get a little more creative with how you mount it. You might not necessarily want to mount it to the ceiling. You might actually need to get a sheet metal contractor involved in that situation. That's just one of those ones. If it's a built-up air handler, there's more to think about than just where you're going to. Placing the air handler or placing the Q-PAC fan is going to be more important. You're going to want to. That's just a bigger deal. But in general, it's really easy if you can easily mount the perimeter angle. Every one of these fan panels is just going to go right and lock with each other, and the installation is simple. But in these situations, typically, especially if it's just 1 Q-PAC fan, if it's 9 or less fans, you're good to go here. You don't need any additional support.
Which way does the angle go?
So the angle is so if this is the L, you're gonna want to mount the Q-PAC on this side of it. So if you try to mount the Q-PAC if you try to mount it like this, then you're gonna hit the screws that are on the back end, and it's going to be a pain in the ass. And that does happen sometimes. So it sounds like you guys have experienced that before.
The guys out of operator, they did it, and they're having to back their screws out, set the panel in, then re-put their screws
Right.
in.
Yep. It's just a matter of switching the orientation of the perimeter angle.
We've seen that today when they built it.
Oh, they did that today?
When they built
When
it.
they did the demonstration, I was like, oh,
Wasn't-
that's why they were having the issue with the bolt.
Yep. There are some nuances like that. That's one of those little gotchas, you know. But that's too bad. Was our guys doing that?
No. Our guys did it.
Oh, okay, okay.
Your guys showed us how to correct it.
Ah, excellent. Okay, cool. All right. Good job. Good job, team. So here's an example of a project that was not structurally secured to the inside of the unit. Very rarely we had failures like that, but it usually just happens because someone is not conscious of what they're actually securing the perimeter angle to. So in this case, it was a perforated sheet metal liner that was inside the unit, and it's like, you know, like that thin or something. And so they shot it into that, and they just put it up and turned it on, and shortly thereafter it fell on the coil and screwed up the coil, and it was a pretty big problem. So it's just another one of those things to be aware of. And I think they even sheet metaled some stuff here. So yeah, there's like extra sheet metal they added up there that they didn't need. So there's some complications to that project. The installer, for sure. I think we still went out and diagnosed it. That's one of the ones, if there's a structural failure, we're probably sending people out there to take a look at it. But, oh, hey, guys. All right, I'm just going to run it back for you. I'm like halfway through. Okay. Yeah, you guys can probably do this presentation better than me, actually. So, yeah, you guys know not to put it on a sheet metal liner, right? You guys not to install the product on like a perforated sheet metal, like thin little thing, right? Okay, kind of figured. Oh yeah. These guys. This was actually at the. Maybe I shouldn't tell you where it was. I don't know. This was somewhere, and it was not good. But yeah, they like I said, they installed the perimeter angle on a weak structure, and then when they pressurized the unit, it fell and damaged stuff.
This was actually a high static application.
This was the NOAA job, right? In San Diego.
This is close to Arctic Circle in Canada.
Really? You sure?
This is Yukon.
Oh.
8 inches of stacking.
And they had 8 inches of static. And it was, so they had a blank off. So that sheet what you see, we were at the max height of our unit.
Oh.
They still have space, so they had a blank off. The blank off was screwed to the perf liner. There's this perf liner, there was insulation, then there was the sheet metal. So
okay.
They missed that.
Thank you for the clarification there. Will.
They ran it to like 4 inches and then
Yeah, and in that situation, the easy way to get around that is you just get a Sawzall or some tool to cut through the perf metal and the sheet and the insulation, and you'll just make a space wide enough for your perimeter angle, and you can just attach it to that. That's what I would think you would do. Maybe there's some air handling unit rules out there that says otherwise, but if it's a retrofit, you can probably get away with it. All right. What was that?
We're doing the job right now that we had on the display that we're using 3-inch C-channels, black iron back to back.
Oh.
Almost like a tube structure.
I was going to ask you about that.
Yeah, we have a picture of it. Yeah, we're literally welding them. So we had to build because they're the multiple.
You have like six Q-PAC fans, right?
We have 6.
3 and 3?
7 apiece.
Yep.
So we built a skeleton of a grid for those 6 and then locked into that.
Okay.
Because we just had what was it, 14 foot high by,
Yeah.
this huge opening, you can't just
Yeah. There's
can't just keep putting the cubes in and they just fall down,
right.
especially on the height.
Yeah,
That is very important.
Correct,
Yep.
we had double height on top of each other.
You spend
Okay.
a little bit of time just making sure you're locking it up structurally strong enough and it's not going to fall down. So there's a little bit of upfront time there, but the install is so easy that it makes up for it.
Right.
But it's worth it. Otherwise you do this. Like you said, you cut out a little bit of the weak stuff, you put something against go right to the wall, or you build that out that's stronger. Either
Yep.
works.
Yep. Yes. Yeah, and there is some design that goes into, like I was talking earlier about just what it takes to do the fan replacement or the retrofit. You do need to pay attention typically to the rest of the HVAC system, and you want to know about that. I'd actually defer to you guys. Like, I mean, how much time do you think you spend like designing the job when you're in the field?
Yeah, look at this stuff. Like we have a couple customers that wanted us to. They were trying to get us to do it, and they were cinder block units. The actual exterior was a cinder block, so like you can't, and it's under suction right now. So like, can you throw a Q-PAC in there? I'm like, well, if I do, it's just going to blow the cinder block out because it's not porous. So then in that scenario, we would have to build we'd have to build a casing inside of it.
Yeah.
That's all. You just have to address it.
Are y'all able to core fill something like that?
Oh, what?
Just to core fill it? Like if you were to core fill the block?
It's just a matter of what's less expensive too. Same thing. You could, and for us as sheet metal workers, we can do that in house instead of. But you definitely can. There's millions of ways to skin the cat.
Yep.
You know, like I'm saying, you just got to think of it ahead of time.
Right, and that, yeah, just
Part
that,
for us is budgeting. It's like, that's where you're looking at a unit and you see the raise we had for that job. You have to price in all the, people budget stuff. I'm like, dude, you have to think about all that when you're pricing it.
Right.
It looks like great on paper, and then
right, and that's why it's going to be really important to partner up with a very capable contractor, and if that is useful. Fortunately for the Weicherts, they managed to bring a boat together, so.
Most are pretty easy and straightforward.
Yeah.
You'll get to select like random, like, oh, this looks different. Yeah, and pause and just think about it. That's all.
This is just another example of a structure someone added. Not a super tricky one, but something to be aware of.
Yeah, so this is the same one after. So we had to go through a structural engineer who brought in. So this is the same one. They straightened it. They put the 3-inch channels on the side, and then they put a larger L on both sides of it.
Okay, so there's 2 of these or 4 of these on that job?
For these, there was a return fan and a supply. One thing people forget is that force is pressure times area. And if you have a very large bulkhead, that becomes a lot of force. So people forget that. This was a very large bulkhead on the supply side.
Okay.
Yeah, so we had a tremendous amount of force on that bulkhead.
Yeah, you give me thousands of pounds.
I know,
thousands.
yeah. It's unbelievable the amount of force that goes on that bulkhead.
Yeah.
what are your bulkheads rated for? Whatever, if we fasten it correctly.
We have actually our bulkhead. So there's a lot that goes around the bulkhead. The bulkhead itself, we've done FDA tests, we've done tests in our facility here. We've gone up to 10 inches on the bulkhead.
Wow.
We've gone up to 11 inches, done an FDA finite element on computer simulation. We've gone up to 11 inches on that, and we've seen less than 0.5%
Deflection, right? Yeah.
on larges.
Like on an iPad.
Yeah, it's about,
On a 1 Q-PAC stack, on the extent 170 inches wide by 140 inches.
Yeah, but your bulkhead can easily handle 10 inches, not to worry about it.
Yes.
That's why you're.
Yeah.
I mean, I guess it does depend on the number. It does depend on how large it is, though, right? I mean, if you have multiple Q-PAC fans in the unit and you're over that 280 width, then you should be aware of that. So, cool. What else we got? Okay, here's some applications as well. So, in general, it depends on kind of what you're targeting. If you're a new rep using Q-PAC and you want to go after a retrofit, you can. We typically recommend you go after more design build stuff. You're either going directly to owners or you're going to contractors. But if you have access and it's appropriate, you want to bid on a planned spec job, then you certainly can, and you can get all of your information from that from that schedule as your budget. You still want to go to the site though, talk to people, get to know them, try to see if there's any tricky stuff in the plans. Look through it, but a lot of times getting your design from the schedule is pretty easy. So that's one way to do it. There's some existing fan configurations as well you want to be aware of when you're doing retrofits for those large double width, double inlet fans. Definitely want to be aware of these different scenarios, especially with the up blast stuff or the down blast stuff. You just want to make sure you have enough room. So if you're tearing this guy out and you need to, and this is your outlet, you probably want to move your fan a little bit closer to the coil, and you want to make sure you have enough room for the airflow to work appropriately there. And if it's another thing you could do too is you could potentially, add some sheet metal to go over that, and you can move over the outlet as well if you tore it out and you put the Q-PAC fan in. So just things to be aware of. There are different application challenges that we've been talking about that you need to make sure you're aware of. So the easiest thing is always the straightforward horizontal airflow through the unit. That's something you can knock down and do really easily. So if you're just, things to be aware of. So. All right, here's a
Question on the.
Sure. Oh yeah, go ahead, Mo.
Any comment on vertical fans? vertical flow having fans horizontally mounted.
Oh, okay. We can do that. I think there's some general guidelines. I think it's if your fan, if you have more than 4 or 5 fans, you might actually need to add some kind of structural support to support the unit. But in general, if it's a smaller system, we see vertical applied Q-PAC fans on smaller units mostly. It'll be like a 2-pack or a 3-pack where that vertical airflow is going through the fan that way. But if it is larger, you do want to you want to call it out on quips or something, and at least bring it up to us, and we can take a look and see if it does require some kind of structural support. So that's where I'm at with that. Yeah, what do you think, Tom? Have you seen any upblast units?
We haven't done one where we have been pricing.
We've been trying to price, sorry, we've been really intrigued.
Like even that
Okay.
one,
By that, yeah.
top row, third from or second, those two, right?
These guys?
Yeah.
Yeah.
Like we've even gone to those and we've said, all right, well, if there's space above, we could just build a box and throw the fans on top of the unit.
Yeah, and that has been done before. I actually have a picture of that later in here. Kevin did a job for a hotel. It's actually pretty great. Where he basically had his sheet metal contractor build a plenum and put it on top of the unit.
Something like that's pretty easy. If there is a weight problem or concern, you could just throw a post on there. Not
Yep.
a hard thing to put in.
Yeah, they're all just examples of projects. So again, you would just demo this guy. Maybe you'd want to put some sheet metal in between the ceiling and the fan. This is maybe a situation where you want to put the size of the bulkhead is smaller than the dimensions of the room. I would recommend, again, give me the full dimensions of the room, so when we price it, you have a little bit of room on price, and you can bring the actual size of the unit down. So this may be a situation where you want to actually have some sheet metal between the fan and the ceiling. Here's just another example of a retrofit. This one actually was the U.S. Steel building in Pittsburgh, I believe. And yeah, it's a large system, and another example of one where it was more of a room than a unit. Actually, this might have just been a really large air handler, but either way, we're capable of doing large systems, and just be aware of that when you're sizing things up. And then factory installs as well. So this presentation has mostly been about fan replacements and how you want to work on those. But we also do offer Q-PAC can go into almost all, if not most, factory or actual air handlers. So if you have a brand new air handler that you want to put us in, there's situations where you can maybe use a selection tool to get the air handler sized appropriately, and then instead of using whatever fan you would get in that selection tool, reach out to us and we can size one up for you, and you can field install it potentially. I think there are still some manufacturers out there that aren't going to punish you too hard for not using the fan in their air handler. I think York is one, but yeah, if you can do that as well, and we can just ship the product to the field, and you can ship that the fanless air handler as well, and the contractor to the field install pretty easily. So even if you might even have like a knockdown air handling unit brand that you also rep, you can do the same type of thing.
We did Daikin.
Okay, cool.
Yeah.
How's that still working with Daikin? Are you still doing that with Daikin?
I don't know is the answer.
Okay.
I honestly don't know the ins and outs of it. I know that a lot of the times when I have seen these in the field, they have been installed in a new install with a Daikin air handler, but with these carrying the weight of the motor.
Gotcha.
With the fan. So I know it's still an ongoing relationship. I don't know exactly how you get from A to B to an install.
Okay.
But I know that it still is an ongoing thing.
Cool.
For sure.
Okay, that is good to know. And that's an upblast one too. So another one. This is kind of a special case. You're not going to see a whole lot of these, but we can potentially do a really large vane axial replacement. I think it was a vane axial fan that John and Tom were talking about in their presentation earlier, but it wasn't quite like this. These really large ones, you have a really high face velocity, or you have a really high velocity of air through the fan. And in a lot of cases, they're pretty far away from the cooling coils because of that, and there might not be as much space in those areas. So if you can get closer to the cooling coil, you can typically use a Q-PAC fan pretty effectively. And just try to get as close to that cooling coil as you can, and then again, there may be some additional sheet metal you have to do. You might have to even potentially build a little plenum, but we can retrofit vane axials as well. So this was just a large one that wasn't really implemented, but we think it should have been. It just didn't quite work out, but something to be aware
Are you
of.
planning to blow it through that vane axial, or are you
No, we were gonna have them.
sheet metal plenum?
We were going to have them demo the vane axial, and then and these are actually, I'm 90% sure that these guys are acoustic. They're silencers. And I think we're going to have them, we wanted them to demo those too, but the customer in this case didn't want to get rid of them. I think maybe it just wasn't communicated how much quieter the Q-PAC fan is going to be, but either way, it would have been possible. We just would have had to move this one a lot closer to that cooling coil. So and there's some plans we had. We were looking at the plans, we're saying, okay, where are we going to put this thing? And we're like, okay, we can actually just install it right there. So that one, yeah, still in design. Probably not going to go through, but we do have solutions for these vane axials. So, and then in other situations, I think this was actually an exhaust fan for I can't remember which facility it was, but this was an exhaust fan that tore it out and actually installed the Q-PAC, and the contractor built a plenum for. So, exhaust fans, as long as that static pressure is 2 inches, maybe a little bit less, it'll work. But just be aware again with that static pressure.
Is there a reason why it's not symmetrical at all? You've got 3 on that side and then I guess some on the other side.
There probably, I'm sure there's a reason. It's probably just airflow, and just the more fans you have, the more expensive the equipment's going to be. So sometimes you're going to want to just limit the number of fans. That's probably part of it. We do like pretty symmetrical systems, but sometimes people they don't want to use as many fans as they don't want to use more fans than they have to. So.